Easter today. Beautiful, yeah. This is the weirdest picture I could find that could capture that feeling. So to get started, my name is Jongboom. I'm a software developer. I live in Amsterdam, but I work for a Norwegian company called Telenor. It's a big telco. It has branches in Russia with VimpelCom. It's basically active in Southeast Asia, Eastern Europe, and the Nordics. And that's completely boring. I mean, this is just one of those big enterprises that has a campus with 10,000 people. What they pay me to do is a lot more interesting, because they pay me to work on a project from the Mozilla Foundation. So I spend basically all my time, while I'm not on stage and entertaining people here in Belarus, on writing code for this, which is Firefox OS. And Firefox OS is real, it exists. I'm using the Firefox OS phone every single day, and it's freaking awesome. And it's, for me, the opportunity to work on a product that you carry around with you every single day, and that you use for an hour a day, that's freaking amazing. Yes, indeed. Now, this talk is not going to be about Firefox OS, I'm sorry. There will be a couple references, but this talk is going to be about offline. And not as offline, and maybe the guy that just introduced me already talked about this, but I have no clue. My Russian is like still developing. Like, why would offline matter? Like, at this moment, why, as a web developer, should I care about making my website, my web application available offline? Now, I want to do a quick survey here. So, could everyone who has an internet connection at home or mobile raise their hand? Don't you guys have internet connections? Yes, indeed, indeed. Even the guys that did not raise their hands, you all have internet, either at home or at mobile. That seems such natural. The internet is like it's there. But if you look at the world map and you look at the dark regions here, these are all parts of the world where people are not as privileged as you are. In the world, there are 4.5 billion people that do not have access to the internet. That do not have access to this big database of all the knowledge that mankind basically gathered together. That's insane. 2/3 of the world does not have access to the internet. But luckily, this is going to change. Firefox OS is one of those things where we want to bring the internet to underdeveloped countries. We want to bring super cheap phones to countries like Bangladesh, where there's 100 million people, out of which only 2 million people have a smartphone. And that's a trend that you will see with all those 4.5 billion people, because all of them are going to come online in the next couple of years, and all of them are going to do this on mobile. And if there's 4.5 billion people that come online on a mobile phone, that's 4.5 billion people, that's like 70% of all your users are not going to come online on a desktop computer. They're not going to come online on a device that's constantly connected to the internet. And if you keep developing the way that we're doing it now, where we always assume that there's a constant internet connection, that our user never goes through an area where there's no connection, where you can't get new data off the server, you're going to have an extremely crippled experience. Your website, your web application does not work the way it's intended to be. And that's why I care. And even if you're like, okay, but I have a couple of years before all these people come online, right? I mean, it's like, if it doesn't happen overnight that 4.5 billion people just like start using the internet. So here's some numbers from a website that I used to work for. It's Funda. It's a property portal in the Netherlands. And last year, already 37% of all the traffic that they handled was on mobile. Next year, in at least the Western world, in the Netherlands, more than 50% of all traffic on the internet is going to come from mobile phones. You have to start thinking about this now. We have to start to change the way that we develop to take this into account. Users. User can be on the slopes and like somewhere in the mountains there is no connection and they still want to use your application. So I spoke just 5 minutes like inspirational talk, and I can do it a lot more. But I figured it's a technical conference, so just let's do it. Let's create a website that also does work offline. And for that I built a simple application. It's like the most simple application I can think of, but it's very useful, proven to me. And it's a currency converter that allows me to type something in Belarusian rubles, then translate it to euros. So when I looked this up, because I wanted a good example, I tried finding the price of a beer in Belarus, and someone said like, yeah, it's 6,000 rubles. And then I converted that to 44 cents, and I'm like, shit, that's awesome. This is going to be a great country. And then I had a beer, and it was 30,000 rubles. So someone gave me some wrong information. Now, this is a mobile website. It runs on a server, and it's accessible over HTTP. So the application is on my own server, but there's also data coming in from a third-party server, and that's the exchange rate. I get the exchange rate back from Yahoo. They have an API that will say like, hey, one ruble is now X euros, or 0.00004 euros. It's a beautiful website, it works great, but I have a European data plan. My data plan does not work in Belarus. So the very moment that I want to use this application, the moment that is useful for me, yeah, nothing. I mean, this application only works if there is an internet connection. And we want to change that, and that's what today's talk is about. So we can distinguish between 2 types of resources in this application: the shell and the application content. Now the shell is basically all the assets. It's your HTML, it's your CSS, it's your JavaScript. If you're building an iOS app, it's basically all the files that are on your hard drive. It's what you package up and send to the App Store. If it's a website, it's all the files that you upload to your web server. Now, if you want to distribute this, it's pretty costly. If you want to distribute this application to an App Store, you have to send it in for review, it costs a couple of days, and even then it's published, and then all your users still have to upgrade. So it's relatively costly to upgrade this. So for example, your exchange rate, you don't want to code it within your shell, because then it's always behind you. So the second part is all the content that comes pushed down from the server, like the exchange rate in this example. These changes can happen all the time. An exchange rate can change like 4, 5, 6, 7, 8, 9, 10 times a day. Those changes are highly volatile. It's like breaking news stories, exchange rates, the news feed for users. You don't want to bake it into your application. It's application content. These changes are generally very cheap. And we need to make this distinction because you need 2 different ways of caching these. So we're going to start with the shell. This is one of my favorite pictures ever. What we're basically going to do is the same way that you're developing a native application for iOS or for Android. You take all your files of your application and make a list out of them. In iOS, you take all your files and you make one package of it and you send it to the App Store. In our case, we're going to list all the files here and let them put in a cache. It's basically the same model, only for websites. Now, and this mechanism is called app cache. An app cache works like this. The moment that a user visits your website for the very first time, everything happens like it would normally do. So there's no negative effect on the site speed. But after the whole page is loaded, the browser checks if there is an app cache manifest file on your server, and if so, it reads that file and downloads all the files in that manifest. It's basically just a list, and stores them into the browser cache. The second request that comes in, a user asks for a resource on your site. It can be a JPEG file, a CSS file, a JavaScript file. The browser does not go straight to the internet. It first checks the app cache, and if it's in there, it can return it immediately. If it's not in there, it will go to the web server and actually request it. So this way, if your application is completely cached on the second request, your user does not have to go to the internet anymore. So your application is now available offline. Come on, wow, so simple. Yes, so simple. So writing an app cache file is extremely easy. You create a simple text file. You store it as .app cache in your application folder, and it consists of a couple of simple lines. The first one is the cache manifest. It's just a header, so the browser knows what kind of file it is. And they can put a comment in with the version number. Because when your app cache file changes, either because of a comment or because you add new files, your browser will re-download the whole website the next time it comes online. So this is a way, because otherwise users will always view the first version that you ever push down to them. And this is an update mechanism. And then you list all the resources that your application uses: HTML, CSS, JavaScript. That's it. For our currency converter, it's a 5-line file that we need to put in the root of our application. So to tell the browser that there is an app cache file, you put an attribute on your HTML element, such as manifest is the name of your app called app cache. That's it. And next time that the browser downloads your page, it will recognize that there's an app cache file and download all the resources in there. And now your application works offline. Now if you want to update your application, and that's going to be required because a user will always see the cached version. The browser will never go to the internet anymore for your files. You can change the version number in a comment in your manifest file. And the next time that a user visits your web page while he's online, the browser will download that in the background. And the moment that the browser is done downloading, the user will see the new version of your website the next time he refreshes. And there's a JavaScript API that tells you like, hey, now there's a new download available. Now I'm completely done with downloading, and you can tell the user, hey, refresh, and you got the latest and the greatest. Clear? Yeah. Good. All right. So that was like 10 slides of technical stuff. And I know there are some people here that are either not technical or like I want lunch or anything like that. So for that, I made like an intermediate slide. And I want to know who here has kids, like little children and stuff. Okay, so I don't have kids at the moment, but this is what I'm gonna do if I ever have them. So the backstory of this thing is that this father watched the Texas Chainsaw Massacre with his kids that night, and then decided to pull this prank. Good, alright, that was completely unrelated, but I'll put wake you up again. If you want to inspect the app cache, you can do it in Firefox. There's the developer toolbar, and it allows you to list all the resources that are cached in app cache. You can also clear your old cache or validate your app cache and see if there are any problems with it. These are some tools that help you with that. Now, don't bother writing these down. These slides will be on SlideShare, etc. And just as a reference, it's possible to view all the items that are cached, and you can clear them or validate them. I thought I clicked that already. And I mean, the same thing happens for Chrome. Chrome App Cache Internal is an internal Chrome page that lists all the app cache resources and allows you to clear it as well. It's very useful during development. If you click the remove button, then the whole application will be re-downloaded. Now this sounds pretty cool, but there is some shit that you will do wrong. I forgot to tell, but AppCache works in basically every browser. It also works on iOS, it works on Android, it works on Chrome, Firefox, Internet Explorer, basically everywhere. So this is something that you can actually use today. Now there's some stuff that you will do wrong, and most people set the wrong MIME type. That's okay in normal browsers, but in older versions of iOS and Android, AppCache will be completely disabled in that case. So that doesn't work. You can have one file for a port, like the list of files that I wrote in the manifest. If one of those files does not exist on the server, the browser will think like, okay, something's wrong. I'm not going to use AppCache in this case either. And you're probably going to develop an AppCache enable at one point as well. And that's the moment that you get completely crazy because some change that you made in the JavaScript file doesn't populate through. It's like, I've been there, it's not pretty. So AppCache. AppCache is not just for doing offline, because AppCache can also be used to dramatically increase the performance of your application. On a currency converter, if I host it on my own web server and I go there on my mobile phone, it takes 1.5 seconds to load over Wi-Fi the very first time. The next time, subsequent requests, they're in browser cache, so it takes 800 milliseconds. With AppCache, it doesn't have to download anything. It doesn't send any head requests to the server. You can just grab the data out of AppCache and then display it. So now, loading my page only takes 300 milliseconds. It's like a tremendous improvement seen from a user perspective. Plus, you don't even need the internet connection for it. So even if you don't really care about offline, you can use it to get like an incredible speed bump. And all now, like speed is the most important part of your web application. Now we talked about the shell, the HTML, CSS, JavaScript, but we'll also need to talk about the application content. Remember, this was a currency converter, but the actual exchange rate came from Yahoo. It's data that's stored on the server that we download through AJAX. This is a simple AJAX request without doing jQuery. Sorry. What we can say is I want to get data to an HTTP GET request to the server at Yahoo. And then I send it off, and the moment that's done, the onload event handler gets called, and I can store my exchange rate in a private variable or in a database or anything. Now the downside here is that if there's no internet connection, this request will fail. So even though my shell is available offline, the user can't get an exchange rate because that data is still on the server where they need an internet connection to connect to. Now here's a very simple, it's like 3 lines extra code that will prevent you from that. The moment that the onload happens, the moment that a user gets a new exchange rate, with a good status code, because your server might also go down at one point, I can now say local storage is a simple key value store that is included in browsers, also included in every major browser at the moment. And I can say my rate is the data that I just got back from the server. Now, the first time that's not very interesting, but it gets interesting the moment that your server returns an error. You can just read the data back, the last successful read data, and use that as your exchange rate. And the same thing happens if there's no internet connection at that point. So there's no internet connection, also use the cached data. And this way, the user will always be presented with the data from your server that was successfully received the last time. So now we've got a shell that's cached through AppCache, and we have the data that our application is made up for cached in local storage. And depending if there's an internet connection, we can either retrieve the new data or fall back to the old data. So suddenly we have an application that we can start up while we're offline. We can also do something useful with it, because the last data that the user saw is also available there. It's pretty cool. I mean, in 20 minutes, we changed a simple website into an offline working application. Something that you can use on the go or in the metro as well. Of course, this is a very simple application, and I'm betting that most of you have like complex applications with multiple pages and huge interactions. We have some tactics for that as well. Just want to do path caching. Don't worry, there will be funny slides like later on. This is the website of the BBC, and using path caching, you can predict what a user is going to do and act on that, and make sure that the data is already available for the user. So on the BBC, there's an overview page, the very first page, index.html, as you wish. And when the user clicks on an item, then a detail page appears with the full content of this article. Now for a user, it's not very nice if he clicks that item and now there's no internet anymore and he can't read the full article. Or he has to wait for a second for this whole data to load. So it's a bad user experience. But it's something that we see in mobile websites all the time. And that's something where native apps do it way, way better. It's in their mindset. But fortunately, we can do this as well. So our get overview page is basically the function that is called the moment that we get all the stories. These are not the full stories. These are just like the headlines and a link to where they have to go. So we receive stories object back, and now we can walk over every of those stories and store them in application cache, get every story and store them in local storage. So much storage. And what we can also do is put an expiration date on this, because especially on a news site, there can be new information, and you don't want to see the user get old information. Is the new data available? You can say if the user clicks this item within 2 minutes, get the data from local storage. If not, go to the server. Except if there's no internet connection. I didn't highlight it here, but if no internet, then always respond with the data from local storage. And this allows for a user to open your page, then go into the metro and still read all the full stories. And the moment that he gets back online, the expiration date happened, and now we will get like the new information. So this way, we both make the website faster for a user to use, because data is instantly available. You make it offline available, but also the moment that there is an internet connection and the data might be old, it will always be refreshed. And the last thing I want to say is if you have images that you want to cache, you can just use the normal browser cache. We say new image and set the source to an image on a server, the browser will store it, and if you have nice expiration headers, that's everything you have to do. Next time you reference the same image, it will just get caught from cache. Beautiful. You don't even have to write like new code for something. So the moment that you open the detail page on your own website, you're going to say, all right, if there's no internet, or if the expiration date has not passed, then return the data from my own cache. If not, get the new data. And now suddenly, we don't just have an application that works offline through app cache, that gets data and stores it. We have a complete flow in our application that we cache. For a user, this is like the best thing ever. If a user would be a dog, you would have a hat on. Did you all see the effect? Because I put a lot of effort in that. Well, I could say like, okay, we're done. I mean, it's 25 minutes. We've done everything. We do path caching, app cache, local storage. But there's also part of the future. I mean, app cache in general works pretty well as long as your application doesn't grow too big. Because, and Jake Archibald wrote a big article about this. Application cache is pushback. And it's true in a way because application cache breaks how the web generally works. Because application cache works great if you have a single page application. If all the data that you receive comes out of JavaScript. Now, that is not always the case. If you have a big website, like a product catalog, with 100,000 products, you can't download everything in AppCache and store it. But you can't put everything in local storage or IndexedDB either, because it's all different, unique URLs. And AppCache doesn't understand that. So, while the W3C, the standards body, was trying to come up with a way to solve this problem, the main goal was, we want to give developers fine-grained control about caching without breaking the web, without breaking URL structures. And this is a new standard, which is called service workers. It's currently in works, it's not there yet, but it's like a sneak peek about how offline in browsers is going to look like 2 years from now. When a user goes to your web page for the very first time, and asks for index.html or any other page, you can now respond with the page, but also with some inline JavaScript. And this inline JavaScript acts as a router, as you know from the server, where you can say, like, hey, if you want a resource that's located under the folder foo, that starts with foo, please consult me. Don't go through the server, but ask me first what happens. You can write a client-side proxy in JavaScript. And now the second request, when it comes in, I need foo blah, it will consult your JavaScript file first. Like, hey, application, what should happen? And you can respond with data that you've already cached. Or you can have a client-side template that you fill with cache data and return immediately. So you're in control if you're getting data either from cache or you go to the server for it. And by doing this, it's incredibly easy to create a similar approach to AppCache, but with full flexibility. Because you still have URLs, and you can program this completely out. So if you want to create a solution like AppCache in service workers, this is how it actually looks like. So on our index page, we have some inline HTML, where we say that for every URL, on this domain, please consult client-side controller. It's like separate threads, it doesn't interfere with your application, it's just a normal controller. And in there you got event listeners. For example, a fetch event listener, the moment that a browser wants to receive some information, like I have a URL, what should I do with it? In this case, if the URL matches something that we can handle, we can immediately respond. We can say, all right, yes, I know what this data should be. Here's like 200, okay, and here's the response. So you're in full control here. And the beauty of it, that if your browser does not support service workers, it will just ignore them. So it's a completely new spec on top of that. So service workers allow you to write a client-side HTTP proxy, like small, where you can control like how offline should do, how caching should do, etc., etc., etc. So this is in the works. There's ongoing work in Blink, the render engine from Chrome, and in Gecko, the render engine that powers Firefox. But if you really want to play around with that, the spec and the proof of concepts are already available on GitHub. Pretty awesome. So, awesome basically sums up this whole presentation. I mean, in 30 minutes, we went over from a mobile website, a mobile application that did not work offline, to caching data, do path caching, whatever. Shit. I mean, yeah, I mean, that's like all I can say about it. But, I know that some people, because I talked to a couple of people, are like kind of disappointed that I didn't talk about Firefox OS, the new mobile OS from Mozilla. And you can totally talk to me about that like after this show. And to get you excited, get you psyched about this, I have a little video that is made by Movistar, a telco from Latin America, and it basically sums up everything that's cool about Firefox OS. And that's my last thing. So when the video's done, you can like clap very loud and cheer.
Menghadapi batu sendiri dalam kasihmu batu kuat bila